today we're going to talk about solving quadratics. It's our last day of this unit, which means we're going to be testing soon, Andrew.
Yay!
No.
So we're going to review on Friday, and then next Tuesday we will be taking our quarter final. Every quarter we will take a final. Normally it will be on the computers, it'll be through Acuity, but they didn't have it set up this quarter, so we had to make our own.
It's multiple choice.
But it is multiple choice.
Okay.
So
For this test coming up?
That makes sense.
yes, the next test will be all multiple choice.
Yeah, I might show my work.
Wait, you still have to show your work?
Yeah. Multiple choice.
He's a very good guesser, so he might come through.
Have you guys gotten your results yet?
And we will also be grading notebooks next week. Next week, your notebook should have everything I've handed back to you in order, in their own.
Don't they say?
That's why I did all those notebook checks at the beginning of the quarter.
How many points is that worth?
100.
Nobody.
100 points?
Yep, that's what I said multiple times at the beginning of the quarter. Ashley, do you want extra credit? Nope.
What if we have the
Anyone
paper?
told you you're like the exact opposite of Kirsten Stewart? Instead of always having like a straight face, you're always smiling. Like even when you're pissed off.
Oh, Kristen
you're always-
Stewart, who can't act.
Yeah,
She
she
has
can't
no
act.
facial expression.
She's got a permanent.
Hey, I love Kristen Stewart. I said hello.
That's no.
Okay, also remember.
What'd she say? Wait, what'd she say?
Also remember, all late work is due Friday.
Hello.
Okay. Dental announcements. Let's talk about solving quadratics by factoring now. So our goal is to solve a quadratic with 3 terms by factoring. When we had 2 terms last time, we could solve it by square roots. But now if we have 3 terms, we have to solve it by factoring. If you can factor, no. If you can't factor, yes.
So it's hard. Hello.
So, when we are solving a quadratic, when we actually solve a quadratic, when it's equal to 0, we're finding a specific set of points on this picture. When we solve a quadratic, we are specifically finding the values where we cross the x-axis, which we call the roots, or the zeros. Guys, I need you to quiet down, please. So we're going to find the roots or the zeros. So we have to do that by factoring. So we have to remember, how do we factor something like this? I think I heard someone say, how do we factor something with 3 terms? Box method. Okay? So we need to multiply first times last. We ignore the equals 0 for now. It's not going to affect our factoring. We multiply 1 times -40. If you still need help with the box method, you could go watch the YouTube lecture again, or if you need some tutoring, come in before or after school. We need factors of -40, so things that multiply to be -40, but add to be 3. So what are some things that multiply to be -40? -5 times 8, which is a good set of factors to start with, because what happens when we add them? They add to be 3. -5 plus 8 equals 3. We're good to go. Those are the factors we want. So once we found the factors, we could set up our box. Our box has 1x squared, so the first in the first corner, the last in the last corner. And then our 2 factors, but what did I have to attach to my 2 factors? X. So we have -5x and +8x. And now we greatest common factor. So in each row, each column, we greatest common factor. So in that top row, we have 1x squared and 8x. What divides into both 1 and 8?
1x.
Just 1, and then we attach an x because they both have x's. So 1x. Now, when we have a 1 next to an x, we don't have to write that 1. In this case, it will be much easier for us if we do not write the 1. So I'm going to start leaving the 1 off if it's next to a variable. What about 5 and 40? 5, but it should be negative because the first one's negative. We go down, we get 1x again, but we don't have to write the 1. Then we go down, we get 8. Just 8. So we get x plus 8, x minus 5. And now we have to not ignore this equals 0. We did our factoring, but now this equals 0 is going to come into play. So let's think about this. What numbers could I find? Let's start with this one. It's easier with the minus. What number could I plug in here and make 0? Positive 5.
Yeah,
5. Because if I did 5 minus 5, I would get 0. If I did 5 plus 8, I would get 13. What's 13 times 0?
0.
Still 0.
Genius.
So it didn't matter that the other one was some other number. If either one of these is 0, we still get our answer of 0. So let's start again. Let's try this one. What number would I have to plug in here to make 0? We're trying to figure out what could I put in here to get an answer of 0. So if I plugged in negative 8, I said I'm going to make x negative 8. That means x also has to be negative 8 over here. Negative 8 plus 8 is 0. Negative 8 minus 5 is negative 13. And what's 0 times negative 13? 0. Anything times 0 is 0. So, did that work? Did it matter that the other parenthesis was not 0?
It did not.
It did not, because when we multiply by 0, everything becomes 0. So, when it's a really simple factoring like this, where we can think about it logically, we could just think about what the answers were. But what if it's a harder equation to solve? We need a method to solve this so that we don't just have to guess and check and plug in numbers every time. So even though this worked, we want a different method.
Why?
Because these are really easy to think about. They're not going to all be that easy. If we have something that's a little bit more difficult, we're not going to be able to just think about it and say, okay, what number could I plug in here to make 0? We're going to need a way to find that number every time. So if I take x plus 8 times, I'm going to do a different color so that it shows that we moved on to thinking about something different. So if we have x plus 8 times x minus 5, we said either one of those could be 0. It doesn't matter which one is 0. If the left one was 0, we'd get 0. If the right one was 0, we'd get 0. So we can do what we call the zero product property. We can take this and we can split it into two equations, because I can say if the first one is 0, I'm happy. Or if the second one is 0, I'm still happy. It doesn't matter which one is 0. So I can make two separate equations because either one of those will be my answer. We're going to have actually two answers for these equations. So if I go and solve this equation now, how do I solve x plus 8 equals 0? Negative 8. Now, we are ignoring this second equation. These are two separate equations now. So we get x equals negative 8. Was that one of our answers that when we went through and logically found it, worked? Did negative 8 give us 0? Yeah. So this is showing, yes, this process does work. I could also add 5 on the other equation and get x equals 5. So this is called the zero product property. And it only works if we're equal to 0. If we're not equal to 0, that would be a problem. If we are equal to 0, then I can split it into two equations. If it said like equal 15, I couldn't say x plus 8 equals 15, x minus 5 equals 15. Because 15 doesn't have the special property 0 does. So from this discussion, we've learned two things about solving our quadratics. The equation must equal 0, and you will get two answers. So those are the main points from this first discussion. We have to start out equal to 0, and you will get two answers. And the reason we get two answers is because it's a quadratic. When you have an x squared, that squared tells you, hey, this is going to have two answers. I'm going to pause for a second while everyone catches up to this point, and then I'm going to move to the next page. Yes.
Can I use the whole pass, please?
Here.
Oh, right.
I've been waiting.
I think,
How's that?
Someone's taking it down.
Took a while.
realize we're recording, right?
Oh.
Not listening to me anymore. Okay. Let's go to the next page.
Dropping some logs.
That'd be funny. If she fell asleep in there.
Wait, I didn't get the second part.
You will get two answers.
What was the second part?
Two answers.
Get two answers?
Yeah. One try problem, but yeah. No. Okay. Just do notes. It's not mine.
Notes?
Okay, 3x squared equals negative 11x minus 8. So we said we can't use the zero product property unless we're equal to 0. So if it's not already equal to 0, we need to make it equal to 0. Get equal to 0. We have to go through and get this equal to 0. So it doesn't matter if the left side is 0 or the right side is 0, but we do want this first this first term that has the squared to be positive. So I like that 3x squared is already positive, which means I'm going to move everything from the right over. So how would I move negative 11x over to the other side?
You're gonna add 11.
Add 11x. What you do to one side, you have to do to the other. Same thing with 8. I'm going to add 8. So if everything cancels out on the right, we get 0, which is what we wanted. We wanted to get 0. So on the right side, those things canceled out. And if we do plus 11x on the right, I had to do it on the left. If we do plus 8 on the right, I had to do it on the left. On the left side, is there any of those numbers that could combine? None of those are like terms, which means if they don't combine, I'm just going to write them from left to right. I'm going to say 3x squared plus 11x plus 8.
Nobody here has erasers. Mine's the worst.
Oh.
For ice
Okay, so none of those would combine. We can write them on the left. So when we are factoring, we did this more when we had our factoring unit, but we haven't talked about it for a while. Demetrius, go away.
Demetrius.
Um,
Can I close the door?
not right now. We always had to check for something before we factored. What do we check for first every time when we're factoring? Greatest common factor. So we need to check for a greatest common factor.
Take your time too.
Okay, and I heard Hannah say the greatest common factor would be 1. If the greatest common factor is 1, we skip this step now. In the past, we actually wrote it out. We don't have to write it out anymore. If it's 1, skip the step. If it's a different number, still write the step in. But we can skip that step now if it's 1.
If 1, is that 1?
If 1. If it's a 1. So we skip greatest common factor because it was a 1. And then we go on and do box method. So looking at 3x squared plus 11x plus 8. We have to multiply two numbers together. What two numbers should we times together?
3 and 8.
3 times 8. So we want numbers that multiply to be 24 but add to be 11. Numbers that multiply to be 24 but add to be 11. 8 and 3. They happen to be the same as the ones we used. Doesn't always happen, but it can. So our factors are 3 times 8. We set up our box. So we put our first term, 3x squared, in the first corner. Yes. Okay. Looking at the top row, what divides into both 3 and 3? X does what else? 3. Yes, 1 would divide into both, but we want the biggest number. 3 is the biggest number. What about the second row?
No way, I thought I was
8. What about the first column?
1.
This time it's 1, x, and 1 for the second column as well. So now we write out our two parentheses. We have x plus 1, 3x plus 8 equals 0. And now we use the zero product property, which means we'll split it and solve. So we split it into two separate equations that we solve separately. Two separate equations that we solve separately. So I would have x plus 1 equals 0, 3x plus 8 equals 0, and I solve each of these equations just like any normal old equation from last year. So solving this first equation, I minus 1 from both sides. So the first equation is super easy. The second equation is going to take a little more work. Not a whole lot more work, but a little more. But we still start by taking care of the plus piece first.
-8.
So to do that, we would use the opposite of minusing 8. So we minus 8 from both sides. But that's going to leave us with the 3 that we still have to take care of. Okay? But it comes out of 0. Okay, so Zach said divide it, and then Carly said, well, that gives me a problem. That would come out as a decimal. Negative 8 over 3 is going to be 2.66666 forever. Okay. So if it comes out as a decimal, let's leave it as the fraction -8 over 3. So I'm going to have you guys try a problem, but I want to help get you started on it because this one will have a greatest common factor. And we have to refresh how to do greatest common factor. Not yet.
But today we do.
Yes, so we do have homework. I will not hand you the homework right now. We're not done with that.
Are we gonna get it in like the last minute?
It'll be pretty close to the end of class. Okay. 6v squared minus 24v minus 72 minus equals -2. How do I get this equal to 0? You said 72. Sorry. 74. Add 2 to both sides. Calm down, everybody. I put it under the 74 because those are like terms. Those can actually combine together. So we have 6v squared minus 24v minus 72, which is probably why I said 72 before, equals 0. So we did our first step, now it's equal to 0. Okay. We can't do box method until we do check step 2, greatest common factor. Does this one have 6? A greatest common factor. 6. Okay, we might have thought 2 because 2 does divide into everything.
But it's not the greatest common factor.
But it's not the biggest. So, we handle greatest common factor differently when we have an equation. Instead of putting 6 out front and then doing parentheses, we're okay with just dividing everything by 6, even the 0. So if I divide everything, 6 divided by 6 is 1. I don't have to write the 1 in though, because it's next to a variable. 24 divided by 6 is 4. 72 divided by 6 is 12. And then what? 0 divided by 6?
0.
Still 0. So even though we divided, we still have the requirement of equal to 0 there. So now I want you guys to finish this problem. I'm going to give you about 5 minutes. Box method and solve. Split and solve. Okay, I need everyone's attention back up front. When you factor, so I'm going to skip the box method right now. We've practiced it a lot. When you finish the box method, you should have v minus 6, v plus 2. You could have the opposite order and still be fine. If you put v plus 2, v minus 6, you're okay. Now we need to split and solve. Guys, I need you to quiet down, please. Thank you. How do I solve the first equation?
Plus 6.
Minus,
Plus 6.
that's 6. You know what? Mine's a little slow.
It's okay. Or, on the second one, we minus 2.
Don't you box method?
What?
Yeah, but after that.
Yeah, I skipped the box method. Because you should have been doing that on your own in the 5 minutes that...
So if we did it the other way around, it would be v equals -6 and it's just
if you did it the other way around, you should leave the positive with the 2 and the negative with the 6.
I don't understand.
What do you not understand?
Oh, shoot.
Okay. So, guys, please quiet down. We're not done yet. I can relate this to the graph. We said these were where our x values were on the graph. So if I drew a graph where we hit the x-axis is that point. 6 would be here. -2 would be here. I could draw an approximate picture of my graph.
Oh, wait.
No, you don't have to draw the graph. Sorry, I think I left copies on.
Did you switch the numbers up top? Is that why?
I was showing you could write it in the other order.
Because I got -6 and +2.
Yeah.
No, like the final answer.
Oh, then you had your signs wrong when you factored. We had to equal a -4 if you have a +6 and a -2. That equals a positive 4. Guys, we are not done yet. Shh. Be quiet. Okay, I could draw the graph. You're not going to have to draw the graph, but what I am going to do is I'm going to give you a graph, and you're going to have to get back to here. So if I gave you a graph, what value is this? 6. What x value is this? Y value is 0. What x value is this? -2. What does that match from our problem? Matches the answers. So how would I take these answers and get back to here? Daniel, how did these answers change? What changed from here to here about this number? Went from negative to positive. What about here? Positive to negative. It just changed signs. So let's try an example now.
Oh my. Oh, so we don't even have to do that.
The problem is, so you can do that with all the easy ones. If there's a number in front of your variable, like 3x minus 5, then you can't just change it. You've got to do the whole equation. Okay, 2 more examples and then we're done for today. These are quick examples.
Only 2?
So shush. We're going to find the equation. I've already written in what these were, because I forgot to erase them from last class. Guys, you would just be given the picture and we say, okay, what's that coordinate? 1. What's this coordinate? -4. And then what did we say we have to change when we put them back into the parentheses? Change the sign. Instead of -4, I use +4. Instead of +1, I use -1. That's all I want you to do on that problem.
Holy guacamole.
All I want you to do is to be able to identify from the graph what numbers we would put in here.
It's so easy when it's
So let's go ahead and stop there. We didn't get through everything I wanted to today. We did A Day. I don't know why we didn't today. So you're going to be cutting out a few problems. You will not be doing problems 11 through 16.